Alright, I'm going to try to give a quick overview of how I enclosed and winterized my pipe setup. Because of reasons of some of my piers were leaning past the outside edge of the house, I wasn't able to go the simpler but probably more expensive route of just enclosing the whole bottom of the house. So I decided to fabricate a enclosure to completely enclose the whole parts of the house that the water pipes were running through. This was something that worked out better for the way that I was doing my pipes. Okay, this looks upside down, but it's more logical to how the house lays out. The first thing I did was I ripped out all the copper. All copper has been completely replaced with PEX lines starting from the far sides here and here. I had the PEX where it runs through the joist. I have it very close to what would be the floor. It would seem the ceiling if you're under the house, but we'll say the floor. And then through every joist spot, I dropped it. No, every second joist spot, I dropped the height of where the PEX were running through 1/16 of an inch. That way, if I ever have to drain the line, the whole thing is gravity fed. From here to here, completely drains out, and from here to here, completely drains out. I have a drain out valve in the heat box I made in the middle. Now I ended up changing some things after I made this, but this was the general layout. I wanted to mark to have just a draft of what I was doing to get an idea of what I had, and all these are marked per joist. All these units right here were where I had to make specific enclosures in between every joist. The ones like this is where I just had a straight run to where all I had to do was enclose plywood in between the existing joist. So when it ran vertical with the joist, it was really easy. I just put plywood covers over the joist and in butts on them. But when it went through the joist, I had to make specific enclosures for every part of these, and that was probably the biggest headache and brain work of the whole deal. It took me a while to really consider the best way to fabricate this, and I even after I thought I had it, I changed some things at the last moment. So I'll start walking through them, and I'll give you the relevant details the best I can remember them. Okay, here, this is just where I changed the water main. It used to run up from here straight to the top of the house. It was copper, and of course I've switched all this to PEX, and these are shut-off valves. I've got it to where I can drain out the cold and the hot. They don't have actual drain outlets on them at this point, but I added those later in the project. You'll see later, but that's just the gist of going up to the lines up towards the house and how they ran around and stuff. And I put a brick here because I guess mainly for added insulation and to keep this pipe kind of where I wanted it, because later in the project I built a actual heat unit, I call it a dog house, around this area of it that holds a space heater or heat lamp depending on what you want to use. I had a heat lamp. I ended up switching to a space heater just to be safe. Okay, this is just kind of a different view of that, and these right here, those were those vertical runs I was talking about. It was really easy because I just enclosed plywood from here to here, lengths of plywood. That was really, really easy to enclose. When the pipes were running this way, like horizontal with the joist, that's where the headache was and the big deal of the enclosure. As you can see, I'll probably tell you a bunch of times, I made very sure to try to backfill with spray foam and caulk any and all cracks that were along or anywhere the system would be enclosed, because the point was I was trying to make an airtight system to obviously not heat the inside, just heat where the pipes were. Okay, let's see. This is one of the only existing copper pieces, pretty much the only existing significant length of copper, and that's just the water heater drain out valve. That's pretty much insignificant. It won't freeze because it's only utilized when the water heater overheats and it has to either overflow or let out steam bursts, and mine never does, so I left it in there, but it doesn't matter because it's not actually filled with water. Everything else has been replaced with the PEX pipe. Like I said, every second when it's running horizontal like this, I start it up high towards the floor, and then every second set of joist I dropped the marking for where I drilled the holes 1/16 of an inch. That way the whole way down it's running like gravity fed for when I drain out. Let's see here, nothing that significant. This is where it was connects into the water heater. I left about 2 inches of copper pipe run off the bottom of the water heater, and I used gator bite attachments to get the PEX into the water heater copper pipes, and so I had to use 2 gator bite attachments. This is just a little look at some of the setup around the bathroom area, which was the hardest area to enclose for the fact of maneuvering and measuring many different pieces of plywood, because I had to cover from back here all the way up to here, and then that length ran up to here to run to the heat box. So there's a lot of places I filled in with the spray foam. This is an access hole that went under the bathtub. At first, I completely filled this in with the spray foam, thinking it needed to be sealed off, but then I got to thinking about the parts of the system that runs behind the bathtub for the shower head and everything, so I ended up cutting out a big square to allow ventilation from this heat unit up into the wall behind the shower, so it would keep the shower fixture from freezing up, things like that. Okay, here is a pipe. I mean, like I said earlier, I went through a lot of trouble to make sure the whole system was sealed. So everywhere the PEX went in the house, I sealed that. Everywhere PVC went in the house that was within that air system in the flow of the area I was trying to heat, I sealed all that. This is just where I had some PEX going up through the floor. Like I said, everything when it come out of the floor, I started as close to the floor as possible, with the exception of still being able to get the PEX clamps down. And then I put a slow incline on everything, running through all the way to the middle of the unit where the heat box is, control panel, whatever you want to call it, heat box, where the heater is and where the drain out valves are and stuff. This is just a close-up of the drain out valves. You can kind of get an idea. This is where the heat box is, if you remember the first picture, and basically we got some stuff that runs over this way towards the bathroom, and then it goes up here and then over here towards the kitchen on this side. And this is where it takes a corner at the end, and you can start to see the one where I did the first side of the fabrications of the horizontal runs with the joist. So these sides were really easy. I measured. The only thing hard was all these joists are at slightly different measurements. I had to measure them all and custom make all these pieces of wood because I wanted it really tight to where I could seal with caulk only for this part. So basically I measured all these, and this is just one flat panel, and it's screwed into this. There's nothing going on at the top here. It's just held in by the force of these screws and sealed up with the caulk around the tops and the sides, like so. You can tell it's screwed in here, nothing else. Caulked here, and here. Sometimes I had backfilled some of the caulk running along with these joists down that way just to make sure everything was airtight. Let's see, not a whole lot of significance there. You can start to see the pieces I was fabricating for the horizontal runs. I'll get into that later. This is part of the point of the vertical runs. I could have went really hard and measured from joist to joist and try to mark all this stuff out, but what I ended up doing was I made them approximately as long as they had to be, and I had a friend help me hold them up. Then I screwed them in. Then I went alongside all the joists that run in that way, and I just marked alongside the joist. And the reason I did that because I needed to know where to put these 2x4s. They come in later in the picture. These 2x4s I actually screwed in this way, and that's what allowed me to create the other side of the enclosures. Remember I showed you earlier I had them screwed to the 2x6, the main ones going down the side. Well, on the other side there was no 2x6, so I had to create this steel in order to be able to screw into to create the other side of the enclosure. So you got the just plywood squares on this side were anchored to the 2x6. Then the bottom was created out of plywood, and I put these chocks in there so I could create the other side and anchor that other side to these chocks. So this is the whole piece after it looked like, or what it looked like after I got done fabricating it. If you can look closely, there's some little niches in it. Here I dropped it in about 1/4 inch, and here it goes down about 1/2 inch. This is because some of the twisting of the main support beams down the middle of my house, it had twisted over the years. So in order to accommodate that, I did have to make some indentions and stuff, but it was all necessary for getting it as airtight as possible. And you can see all the butts after I was done. That's the gist of that. You can see all the marks from where each of the joists were running. Another picture of it, it was just laying there, I don't know, insignificant. Alright, this is kind of a close-up of what I do with the PEX pipes. I can't remember the significance of why I offset them. Oh, I remember now, because in order to get the clamps on where they came out of the thing, you couldn't really have these like coming out the same area, so I offset them a little bit. But nonetheless, like I said, each of these holes, they drop a 1/16 of an inch every 2 joists. That way it's a gravity fed drain out all the way from one side to the middle. And this hole right here, this is part of the whole system. The plan was and it's worked so far, that's why I'm making the video. It's about the end of the winter and I've had no freeze ups yet at all. Anyways, so I got a heater in the middle of the system. The heat goes through here, follows through these holes. These holes are bigger than pipe, and these holes aren't sealed, they're wide open. So the pipe's about a 1/2 inch and these holes are about 1 inch. That way the space right here is carrying the hot air through the system, and when it gets to the end, it's coming back through these lower things like a cyclonic action, because the hot air rises, the cold air moves down, and this cold air moves the heat box, gets heated back up, gets pushed through, goes through the top. So the whole system operates on a cyclonic action. Towards the end of the project, there were certain areas I wasn't for sure would get enough cyclonic movement or airflow, so I did put some extra lower holes in certain areas, but for the most part it remained pretty much like this. And if you do a system like this, you can leave that up to your own judgment. Another close-up of the holes. Like I said, you got the hot air goes in, the cold air goes back this way on the bottom because the cold air sinks and the hot air rises. You can see on the inside where I seal all this up with caulk. I sealed them up on both sides. I wanted it to be very airtight. A lot of times I caulked up areas like this, and I sprayed foam anywhere where there was massive gaps, or even any gaps, period. I try to completely kill and seal every single gap I could find. Insignificant, just showing some sealant. Another place where I sealed in, going through the floor, I tried to make sure everything was completely airtight as possible. Let's see, that's just showing some markings. Okay, right here you can see I was talking about the how I had that bottom piece I fabricated where I had to lay it up, had a friend hold it, and I marked all the joists. This is the twist I was talking about that I accommodated for. It goes from here all the way down this like 8-foot length and then goes back out to normal here. So I'd accommodate for this difference between that and that and that and that within that piece I made. So it's all things you gotta look at and consider if you're trying to make the system really airtight and actually make it work. And these are the bottom holes for the cold air return. And like I said, the top holes going bigger than the pipe for the hot air going through the system. Some more examples. This is the actual part I was talking about, that differential. After I was done, before I sealed it, I got it pretty close, and I went back and spray filled all of this, and now it's airtight. And another close-up of that difference. This is a difference on the other side. Like I said, it was like a 1/2 inch different on that side. But so it wasn't completely in line with this wood, but it didn't have to be. Like I said, I went back and did all this stuff with spray foam. But generally, it's within a 1/16 of an inch. So this is the side view of that part I was talking, the bottom panels that I had to make. So like I said, I had a friend hold this up. We screwed it up in here, and then I went through and marked all these. After I marked all those, I took it down, then I put these butt pieces up, and these butts are chocks. That is specifically for when you put these back pieces on that will enclose it. This is what you anchor that to. I just anchored it to the bottom, and you got one piece that goes in here, and then this whole little square here is enclosed within itself. And then of course afterwards you go back in and caulk it and everything. But that's the best way I could come up after a lot of thinking to do it without actually way over fabricating like little wood frames within the whole thing. This is the best way I come up with. Seemed the simplest, best solution, easiest fix. Here's another view of those, from side to side. Like I said, I went through and marked all these along the joists as opposed to trying to measure the whole thing. It was way easier. This is just an example right here of some of the things you got to watch out when you're making a system like this. You got to backfill any kind of cracks like this, because if I didn't backfill this where the spread is within past this, it would have been within this enclosed system, what's supposed to be enclosed. I would have a major air outlet within that, and then anything past this point in the system, most of the hot air would have been coming out here. It wouldn't have been feeding back down here. Another example is right here is another place that I filled in with the spray foam. This right here is just, I'll show you for a second. These holes, or these what looks like metal rivets, are actually the screws that went down through these. I used really long ones, so afterwards I went back over and I ground them off. If you do this, you'll want to keep like a water bottle or a cup of water with you, because after you ground them down flush, they're going to be red hot and it will burn through your wood and burn the threads out. They won't hold secure. So as soon as you get done grinding them, sometimes before you're done, you'll want to wet these down so it doesn't burn out the wood and basically release the threads of what are holding those chocks to the woods, or the pieces of wood, the plywood. And this is just a small area. I had to run some speaker wires and coaxial cables and Ethernet stuff like that through in the living room. So, I just cut a little notch out of it, whatever, went back and spray foamed that later. Some more examples of filling in little gaps with spray foam, I guess. I don't know what the hell that is. Fucking, sorry, excuse the language, a pile of bicycle rims. Okay, this is just showing part of the main there. I guess you can notice here that gravity feed I was talking about, it's really pronounced within this area because this is where it all just drains out, but through the most of the rest of the house it's just gradual drop. And as long as you do have a drop, that's going to allow the whole system to pull out with gravity. If you don't make sure it's all at that slight angle, you can try to drain your system and think you're good, but I don't know if it would matter on PEX. They say it wouldn't, but if you had copper lines per se, not having it completely drained, even though you open up your lines, if you got water trapped in there, it can still explode your pipes. So another kind of insignificant view. This is all crazy stuff I had to work around while I was building. I think I ended up taking a sawzall and trimming this piece shorter because I was going to try to work around it, and then I realized the way it was sitting, it wasn't touching this rafter and it was touching this one, so I had all this extra length. I just cut that off and out of the way. Yeah, from like I think from like down here it wasn't touching here. I ended up just cutting this off. Just more random views. I had some of this aluminum flashing laying around. I ended up using that to enclose the bottom of my heat box. You can't really see it, but this is, after it's been enclosed, this is a channel that runs way back here. This is one of the easy channels like I was talking about, where you just come from here to here with the plywood because the pipes are running vertically with the joist. So basically there's just a long piece of plywood that goes down this channel. You can't really see it, but those were the really easy parts. Let's see. Insignificant. Okay, now you can start seeing that I'm building the box, and I built the box around where the main came through the ground, obviously, because you don't want your main freezing, and it's around the area where I have all the drain out lines, which I would imagine is standard plumbing procedure. And and there you can see that channel a little bit better. Like I said, it runs down here in this part. The enclosing of these long channels is really easy. The box building wasn't so easy, but it was fairly rudimentary carpentry. I just anchored these 2x4s here up to the joist, 1 or 2 on each side, and then I created these pieces here to kind of hold the whole thing together on the top and the bottom, the same difference. And this is, you can see some of the frame and how the main and the drain outlets are enclosed within that frame. This is a side view. Thing to note about is I didn't make this frame touch the ground. Excuse me. It's because if it touched the ground, it would risk dry rotting and such over time, and I didn't want that to really be an issue, even though I ended up backfilling the whole thing with dirt. But in general, I didn't want the wood touching the specific ground on the ground level to where the water would be running through under my house. So I let the whole thing hover anywhere from 6 inches to a foot off the ground. You can tell back here too how it hovers, and it's a better view of the box. And I end up enclosing all this with plywood. You'll see later in the video. I only brought the plywood down about here because it kind of goes back to avoiding the water. So from about here down to the ground, I dug it all out a little bit after I was done, and I used that flashing that I was talking about, and I wrapped the flashing around the whole thing. That way the flashing was connecting to the ground. It was keeping the airflow out, but I can pile dirt and clay and mud up against that and create an airtight seal and not have to worry about the flashing rotting because it's aluminum flashing. Just another view of it. Another view. Another view. Just another view showing the proximity of the ground. Another view. Another back view showing how the water lines. It's kind of showing the detail of that length that I was talking about that I ended up enclosing. Another view of the feet. Bottom view. Let's see. It's a view going up through the box looking at the ceiling. I have no idea what that was there for, but it had some significance. I forgot now, but if you have to do it, you'll figure it out. One thing you want to do if you do a project like this, make sure you get the best quality screws you can get. The ones I ended up going with were stainless steel heads with the square heads, stainless steel screws. Everything else I had kept breaking, and when you're doing something like this, you really don't want to have to mess with brakes, because if you can't get the screw out, you end up having to grind shit down, and oh man, it's just a pain in the neck, especially when you're around pipes and stuff. You could risk hitting them and have to replace a whole length of pecs. Just some more details on that box, how I anchored them up to the joist, sealing everything in that box. I ended up going back around any loose parts of it. I backfilled with foam, and any parts that weren't really big enough to handle foam, I hit with caulk. And one of the way I hit the foam in tighter areas than you would usually be able to was before I sprayed the foam through the tube, like the first shot, I heated up the end of the spray foam nozzle, and then I crimped like 3/4 of it with a pair of needle nose pliers, so the end of the nozzle where the spray foam would shoot out was only about 1/4 as big as it was from the factory. That way I could really use it to get in the detailing cracks and lay in real thin beads of the expanding foam. So that helped a lot, to where places I probably would have had to use a fair amount of caulk, I was able to use the spray foam and get it injected fairly deep up in the cracks, which would have been harder to do had I not crimped that nozzle. Another look at the long run by the main heat box. Okay, this is after I had enclosed the heat box with plywood sides. What I was getting at, I put it back on. It's got sides and everything. I've got hinges. I put a locking mechanism on it. I don't actually lock it because I'm very far out in the country, but if you were afraid somebody would sabotage your setup or unplug your heater, you could lock it. Mainly my locking device, the latch, and whatever they call it, tongue and groove latch or whatever, that was just to hold this door shut. And I have some of that black cushion window seal foam, like stuff they put around an air conditioner. I ended up doing that around this whole door. You should be able to see that. I'm going to make a video after I go over this and attach it to the end of this, so I can give a quick walk through of an actual video view of all this. So yeah, nonetheless, this to this, there was still like a 1/16 of an inch of an air gap in certain spots of it because wood's not perfect. So I ended up lining that whole thing with that sealant foam type stuff, foam tape, I guess, insulating tape. And you can see here where I finished out the lines, the drain out lines. I had them run out through here. I backfilled that with foam, and I ended up putting notches of spray foam in the end of this. I didn't actually spray it in there because then it would probably go way far back, but I just cut out some plugs and stuck it in there. That way I would have no outside air penetration into this box from here. And we'll go to the next one. There's some more examples of how I really, if you're going to try something like this, you really want it airtight, because if not, you've pretty much defeated the whole purpose of building that whole system. So if you really want it to be airtight, you're going to have to be generous on the spray foam, and you're going to have to be very meticulous and observant of the whole system, all the joists, everything throughout it, if you really want to have a good seal. Because if not, you could easily overlook what would seem to be a small crack, but when it comes to holding in heat in your system in the middle of winter when it's below zero, it can be a significant crack. So like I said, you really want to observe the whole thing while you're building it, before you build it, after you build it. Just go over it all and try your best to get every single little air crack you possibly can closed off to ensure better efficiency of the whole system and your pipe's not freezing. More sealing, stuff like that. I had to avoid this pipe. It was right in the way of the door, so I had to bring the door down a little bit. More sealing of the whole system. Like just in general, you want to go and make sure everything is as tight as it can possibly be. A little close over where the pipes come out the wall there. This is a inside view from the back of the box area. Some more examples of sealing up everything you possibly can. Like I was talking about, I made that small nozzle with the spray foam. Areas like this is where it was a godsend. That would have took a whole hell of a lot of caulk. You got that 1/4 the size spray nozzle and just jam it right up there and give it hell. And when you backfill stuff like this, you really want to make sure the stuff is going all the way up to the top. And it's not so hard to do here, but say you had a 1/2 inch gap, what I learned to do is I would take a piece of cardboard and fold somewhat of a U out of it, one that's longer than this length, and fold it into a U shape and jam it up in there. Then it creates a back wall within that part right there, and you can spray all the spray foam in here, and instead of just keep piling back this way, it'll actually pile up vertically because it's got this wall breaking it, or a barrier or a barricade or a dam, whatever you want to call it. So that's a little trick that helped me along in certain areas too. Up here, more areas of just giving it hell with the spray foam wherever it needed. I ended up, the electrical setup or the heater I used, I piggybacked off a wall outlet. I don't know how safe this is, but considering I don't ever use this outlet, it seemed relatively safe to me. If you know somebody that's an electrical engineer or electrician, you might want to take their advice from it. But I ended up just drilling in through the bottom of the house, on the side wall of the house, and running up alongside, and ran the wire in through the back of this outlet, fished it out, and then, like I said, piggybacked the wire, the electrical wiring off this outlet, and it runs all the way under the house in the middle of that box. And that's where I got a timer unit and my space heater hooked up. So that's just the way I did it. There's probably better ways to do it or safer ways to do it. It's whatever you want to do at your own risk. I'm not a professional, but it's worked for me so far. No hitches. The only one hitch is that space heater runs, so if I plug a vacuum cleaner into this outlet, it'll throw it. So I have another space heater in another room I have to turn off in order not to throw this breaker with that space heater in the house and a vacuum running at the same time. So something you might want to consider when you think about which outlet or which part of your line or fuse box you're going to hook up your electrical outlet to. Here's where I ran it through the floor. It basically goes in through the floor on the outside wall, up through the drywall, right behind that outlet. And it runs down here, and this soon right around here is where it ties into where the whole enclosure system is. And that's just showing it go into the actual area where the enclosure is. Yeah, right there is where it hit, and then it follows along these pipes, or I think it hits here and goes, yeah, it goes this way down to the heat box. Just showing try to make tight corners and pull the wire real tight. That way you don't have to use any more wire than you have to, if that makes any sense. Wire running down all the way into the heat box, and then I've got it penetrating through one of the top supporters of the heat box right through here. Like I said, that doesn't really matter because of this. The heat box isn't made to support weight. It's just made to enclose the area, so it's not going to hurt it to drill through that part of the frame. So I just did that. That way the whole wire was enclosed within the system. I wouldn't have to make any unnecessary penetrations into the system. There it comes. That's where it ran in, and then it comes out this bottom right down the side of the front of the heat box, and I end up installing an outlet there. I don't know if I have any pictures of it, but when I put a video at the end of this video showing some of the details in actual video format, you'll be able to see that. More of sealing in and showing an area like this. If you only have an inch of rafter or joist, rather, you're gonna have to be really careful and have very precise tolerances for the way you connect everything. Because if you see here, this board lays on this about a 1/2 inch, and this board lays on this about a 1/2 inch. So both these boards are sharing this as a support and an anchor point. So, I mean, anybody that has experience with woodworking should be able to do that fine. But an amateur, yeah, you really want to consider if you know what you're doing or not, and if you're willing to undertake it, just take your time and make very precise measurements. And like I said, more examples of everything being sealed up tight. This is where that hot water outlet is, and this is where that wire runs into the whole actual enclosement system. More examples of where I had to grind off for those end chocks or the butt studs, where I was anchoring those the enclosure sides too. And on this part of the run, I didn't have that main beam on either side, so I actually had to put the chocks on both sides to make this actually completely enclosed, because I had to form pieces on both sides. As compared to the other one, I anchored one of the sides to the main support beam, and then I just made the actual enclosures to the chocks on one side. So that was kind of the point of using the beam. It made it a little easier. Just kind of showing you the details of how to work all the plywood around the pre-existing plumbing and stuff. And of course, I went back through all this, gave it hell with the spray foam, backfilled it in really good areas like that. This is the cord that was from the water heater, and before it just ran along or under, hanging under the joist. I had to knock that so I could keep this wire within the system and not have to work any of my wood around that wire. There's no need to do that. I just hardly knocked the joist and it sank right in there. Once again, there's a return hole. Like I said, the whole thing that really makes the system work like it does is the fact that it has holes up high where these pipes go in to allow the heat to go through, and then it has cold air holes on the bottom to allow the cold air to return to the center system to be heated. So the whole thing is kind of moving on the fact of a like thermal dynamics, the hot and cold air pushing itself in a circle, cyclonic type action through the whole system. Very important. There's another side view of that part where I had to do double chocks on both sides. Pretty self-explanatory by now if you made it this far. There's the whole cyclonic coal on the bottom again I was talking about. Alright, and here you can see this is just another example of one of the easy runs. And right here, even though the wood was really close to the joist, I went over and caulked it. I just caulked the hell out of everything. You couldn't even see a gap, but just to ensure the whole system having airtight quality, I caulked every possible aspect of the system I could. Another example of the bathroom. Okay, right here, this is one of the areas where I used a U-shaped piece of cardboard, like a chock of cardboard. Get out of here, kitty. Go for now. Come on, get out of the way. Sorry about that. I used a U-shaped piece of cardboard from here up to here to ensure that this foam, when I backfilled it, wouldn't keep spraying out this way. That was how I got it to raise to the top. I hadn't done it at this point, but after I had the whole system complete, I went through and redid that. And just any area like this where you got gaps or anything like this, obviously spray the hell out of it. More examples of some of the woodwork, some of the working around, some of the pipes I had to do. And some of the areas like this, as opposed to anchor this piece to this joist, I just attached chocks to this area, or actually I attached chocks to these joists here, and then anchored this wood to those chocks because it was easier to do that as opposed to anchoring it to this joist. Not actually on this one, but per se like the one that would go along the side of this one. That was something I utilized in some of the areas to make the securing of the enclosures a little easier. Let's see. Just an example of some of the odd geometric shapes I had to cut out to run along the lengths of the pipes and stuff. And of course, I went back and sprayed the hell out of that with spray foam. Hit all these edges like this and this, all that with caulk. Everything, like you can see here, everything was packed in with caulk. If it couldn't accept spray foam, it got caulk everywhere I could possibly think of, minus the screw holes. I didn't caulk the screw holes because they're tight. That was just an odd shaped back piece I had to get to go around all this. Another example of the back, another example of the back, another example of the back. Let's see. Yeah. There's another example of sealing it all in. This is what it looked like after I closed it up. The only thing that I might have changed after the whole thing was I would have built an area that actually dropped around this J valve. I wouldn't have had to do it necessarily here, but around this J valve would have been good, because when it gets freezing out, sometimes the J valve does still freeze up. And of course, if I wanted to, I could probably just undo this valve during the winter time. But the whole point of that is to keep gases from your septic tank and rising back up through your bathtub areas. They got the same thing in a toilet. But sometimes this freezes up in the winter, which generally the only backlash to that is that it takes a really long time for the bath water to drain out, and it'll kind of leave a ring of grime because it's not draining out quick enough. Some more examples of filling in. Really tight. I went back over this with the quarter size spray foam nozzle that I made on the one bottle after I had done the regular size to really get the big fat parts of it. I went back in with the tighter detailing spray foam to make sure it was sealed super tight on top and bottom of that larger spray foam bead. More examples of caulking the hell out of everything. More examples of spray foaming the hell out of everything. Okay, this is the box. Like I said, I end up going back and putting flashing around the whole thing, and I even caulked in between that flashing and this plywood box. I ended up taking this dirt and this here in between that brick that was around the main and the flashing, the box itself, I backfilled with dirt for added insulation and air barrier to make sure there was no penetration of the outside air or anything into this box from this bottom part. And this flashing here actually runs about 2-3 inches under the dirt. I put these blocks here to keep, because my whole house is on a hill to a degree, I put these blocks here to keep the dirt from washing out as bad as it would have if I hadn't put them there. And then on the back I've got another configuration of blocks. This is just another side view of the front. I ended up moving the latch up higher because it held the door up better up high like that, held it tighter. Okay, here's in the back. I made kind of a T-shape that way, preferring the water would divert around this instead of just hitting it and washing it out from the backside. You know, you gotta create a barrier of some sorts to try to divert your water from running off. So this should, after a couple of years, it'll form its own kind of a V pattern and keep that water diverted off the box area, and that way it won't wash out the dirt or anything. Let's see. Here, like I said earlier, I ended up running the outlet pipes through here and spray foamed them, obviously. And I took little plugs of scrap spray foam I had laying around and pushed them in there. And if I ever had to drain it out, it should just shoot out. If not, I'd pull it out with a safety pin or something. But I did that as opposed to spraying it in there, because if I sprayed it in there, it might have been really hard to get out. And the whole reason I plugged it up was to keep the outside air from going in through these pipes into this box. And I marked the area, the corner of the box that the main comes in through the box, in case I have to do any future messing with the main or digging, or just if I want to build something different, I'll know exactly where that main is under the box. If I have to dig for it, there won't be any questioning and risk hitting into the main with a shovel. This is kind of a view of that actual enclosure, how sealed I did everything, you know, even on that little space between that plywood there, I hit with spray foam and all on the bottom and everything. Close up with that same picture. This is about the best picture of the whole length. Was the hardest length to actually fabricate, like the square enclosures. And yeah, this is just kind of showing you how it looks like after it's done. You can see the areas where I ground down where these butts went in, or the chocks that I anchored to, and this is where I actually screwed in those chocks to hold this plate right here up. Obviously went back and sealed everything with caulk and such. Sealed everything, you know, anywhere where the wood met wood, it was all sealed tight. And so this is the outside of the house. Let's see, and these I ended up doing this at the end. I bought 2 indoor-outdoor thermometers. It reads the temperatures indoors and outdoors via these probes. I had to make these extenders to raise the probes up to a certain level in the box. I secured these thermometers to some of the joists with drywall screws, putting the bottom ones, holding on there, and then screwing the top ones to hold it secured. And these thermometers are about $7 on eBay. They'll record the highs and the lows for indoor and outdoor. The only trick to it was what read outdoor was actually these probes where they were inside the box, and what reads indoors is actually the outdoor exposed air. So if you have to mess with it, you'll understand it, but it took me a while to get the hang of it, and I thought that the system wasn't working at all, but it was actually working quite well. This is, after I had the whole system built, this is a couple weeks after I built the system, I added these monitors, they're temperature monitors, drilled a little hole. I put these, one on the far end on the side by the bathroom, one on the far end by the side by the kitchen, and once again, the things I made, they're extenders to keep these probes right at the middle of the box level. Like the box is about 10 inches deep. This holds it about at a 5-inch mark in the box. That way it's getting the average temperature. If I'd put them 10 inches, it would have been only getting the hot temperatures, the hottest part. If I just put them right in there without one of these, it would only been getting the lowest temperatures at the bottom of it. So I decided to go with recording the average temperature, which is about halfway up, and that's why I made this extender. And I put a little loop in the bottom, that way after I got it up in there, I could anchor it to that with a drywall screw. And after I anchored it all in, I sealed it in with some more spray foam so I wouldn't be getting air penetration there. Then mounted up my temperature monitors, or thermometers, whatever the hell you want to call them. I mounted those up here, and like I said, it'll give me the outdoor and inside the system highs and lows, and you can reset it and everything. They're like $7 a piece. Pretty good piece of equipment, and better than wondering in my book. I spent $15 mounting them, and now I don't have to wonder about what the temperatures are and whether the system's running right or not. Let's see, this is the other side, the far end of the house by the kitchen. I did the same thing. I made a retainer out of a 2-liter clipping with a thumbtack to hold these wires out of the way to keep mice and stuff off of it, because you know how those little bastards are. They'll chew up anything they can get a hold of. More of just general sealing the whole system with much spray foam. And this is the other, I put it on this side because it's more accessible as to going around and looking at it. And once again, those thermometers, they were on right here by the bathroom and right here by the kitchen. That way they're both as far as they can be away from this heat point, because if you measure it here, everything's gonna be hunky-dory. So you want it to be the area where it takes the longest for this heat to go and everything that you're monitoring. So I put them at the far areas. I didn't put one here because I figured that's pretty close to that, and it's close enough to this, it shouldn't matter much. But around here, these are outside walls, and they're the furthest away from the boxes, so that's why I wanted to measure them. And that should be pretty much it. And after this, I think I'll have a video attached of just a little walkthrough, a live video walkthrough of the whole system. Alright, I'm out here doing a little recording of the outside system. Hopefully we'll be able to see what's going on here, although I don't have the best lighting. Ow, shit. Should be able to get an idea. Alright, let's see. I record this and illuminate it at the same time. It's going to be somewhat hard to do. Alright, this is the digital thermometer, hygrometer. It also gives the humidity. I forgot to mention that. So right now it's saying my outdoor temperature is 55. That's actually the indoor. That's what's inside the system. And what it says is inside is actually outside the system. So outside is 53 degrees, inside is 55 degrees, which isn't too bad. It's also got highs and stuff. Let's see. The highest it's been inside the system is 68 degrees. The lowest it's been inside the system is 28, which I haven't had any freeze ups at all. I would imagine I haven't reset these things since I hooked them up. That's probably when we had a power outage and the heating unit wasn't running in the system. So we'll go over and check the other probe. I know, nice and black. Break my neck out here, but it's relevant to the end of the video. We'll do it. Alright, now we're at the other side of the system. Make sure I got a focus or something here. Alright, getting there. Alright, there we are. So right now it's saying the inside temperature is 55, the outside temperature is 51. I'm losing my focus again. I guess you'll have to take my word. Yeah, outside's 51, and this one records the highs and lows. We'll check that. Let's see. The outside maximum temperature this year has been 68, and the inside, or the outside minimum, has been 16 degrees. So we've hit 16 degrees, and let's check the inside. The inside, the maximum temperature inside has been 68 degrees. The minimum temperature inside has been 26 degrees. So like I said, we had a power outage, so it was 16 degrees outside. It still stayed 26 degrees inside that enclosure, even though the heating system hadn't been on for probably about 5 hours, so that ain't too bad. I should reset it, probably get a better average, but I'm not worried about it because I haven't had a first freeze at all, minus this little J-valve guy here that I was telling you about early in the video. I might go through next year and add a box to drop around it to prevent that from freezing, or I might just undo that little cap in the winter. I don't know. We'll decide about that later. We'll go over and look at the box a little more. It's a little more complete than what I had in the presentation earlier. Let's see, it's hard to see, but there we got a little locky deal, and I will proceed. It's a really tight fit, so go in here real quick, getting short on video. I have a timer. It's nice and warm in here. It's hard to see. I have a timer unit. I have that outlet installed now. There's a timer unit on it. It runs about 10 minutes and then it shuts off for 5. This keeps the heater from overworking. It keeps the electricity from using too much. It also prevents the cord on the heater from melting. If you have any of these little space heaters and you run them much, you know that the cords, you give them hell if you run them all the time, even if you got them on low, even if you end up switching the cord with an industrial size cord plug. So yeah, I've got it on a timer and it runs all day this time of year. 10 minutes on, 5 minutes off in cycles. I had a outlet that would only come on. That thing right there only comes on when it's freezing. I decided to go against that and just give it hell with that timer outlet. What I've got is a little ceramic heater here. It's got high and low. I keep it on 3/4 of the way set on the high setting, and so far all winter that's worked great. No freezes, no water leaks. The dirt in here does retain just a hair bit of moisture, but nothing significant. And other than that, the whole system's good, so that should do it. Thanks for watching, and I hope this helps somebody out. Oh, one more detail. There's the I was saying I sealed up the doors with that air conditioning type insulation tape all the way around it. So yeah, and that should be it. So yeah, hope this helps somebody, because it took me a long time to figure out how to do it this way, and this is what I come up with, and it's worked like a charm so far. Praise PEX Pipe. If you have to go to it, it's totally worth the investment. That should wrap it up. Thanks for watching.